This is video 2.2b, okay, which is we are going to cover rational inequalities, okay. The first part, okay, so let's say solve 2x plus 3 divided by x minus 1 greater and equals to 1, okay. Remember, we couldn't just cross multiple, okay, means that, for example, normally when we look at P over Q equals to R, we always said that just bring our Q to the other side, okay, or we just say that we multiple with Q, okay, we multiple Q, so that means our Q disappeared. Okay. Okay. So the denominator will be just some sort like crossover to the other side. Okay. But now, since this one is, okay, let's say I have P over Q greater than R. Okay. I couldn't say that I multiple Q. So this one cancel off. So I P greater than R Q. Okay. Why couldn't do so? Because we don't know what is the value of Q. Okay. Just recall back. Okay. If you multiple with any numbers less than 0, so the sign over here is going to revert. Okay. You're going to change smaller than. So what you need to do is we couldn't do so that just multiple in such a way. So what we need to do is we just bring our 1, okay, to the left hand side. Okay, so I have 2x plus 3 divided by x minus 1 greater than 0. Okay, and then we get the common denominator. So, okay, so then we solve. Okay, we simplify at the above. So we have the x plus 4, x minus 1 greater than 0. Okay, so now this greater than 0, just leave it in this way. Okay, just leave it. Okay, now what we need to do is we try to find the factor. So I have two different factor here. One is x plus 4, another one x minus 1. Okay, remember that denominator cannot be divided by 0. So I have one thing is x cannot be minus 1. Okay, but for this one, x equals to 1 and x equals to -4 is the critical value for us to plot the graph. Okay, to plot the number line. Okay, so now we look at the simpler one. Okay, not the simpler one. We look at the method of real number sign. Okay, so as I said before, we try to let all our factor choose either greater than 0 or less than 0. Okay, it's not affected by these problems. Okay, just because of for convenient purpose, I just choose greater than 0. So the first factor, I can choose x minus 1 greater than 0. And the second one is x plus 4 greater and equals to 0. So we move our -1 to the other side, x greater than 1, x minus 4 greater than x minus 4. Okay. Now, okay, x and equals to minus 4. Okay. Now, what I have is x greater than, okay. So, we're going to have x greater than 1. X greater than -4 is a solid one because it's, okay, it's a solid one. Okay. The one with a line, we put positive. Without line, we put negative. Okay, negative, this is positive. So positive, positive, give me positive. Negative, positive is a negative. Negative, negative is a positive. Okay, now we already have the sign. Okay, positive, negative, and positive. Okay, now we look back our problem. The last one over here, it said that greater than 0, so I'm going to choose my positive sign. Okay, so the positive sign is x greater than 1. Okay, remember there's no equal because x cannot be equal to 1. Okay, sorry, cannot equals to 1. Okay, sorry, this one. Okay, and x is less than equals to -4. So this one is x equal to -4, x greater than 1. Okay, so now this one is a square. Okay, 1 and infinity. Okay, this is by real number sign. Okay, if we want to use table of sign, okay, same thing. I have -4 and 1. This is my number line. Okay, divided into boxes. Okay, we choose a number greater than 1. Let's say I choose 5. a number between -4 and 1 is 0, and a number between less than -4, I choose -5. Actually, it just maybe you say that you want to choose -10, it's up to you. As long as it's smaller than -4. Okay. Now, we put our factor back up here. Okay. You want to choose x plus 4, x minus 1. Is depends on you whether you want to put x plus 4 up there or below is still the same. Okay. So what you need to do is take this value of 5, substitute inside the x plus 4. So it's 5 plus 4 is 9. 9 is a positive. Then 5 minus 1 is 4 is a positive. Okay. Let's say I have a 0. 0 plus 4 is a positive. Okay. It's a 4, so it's a positive. 0 minus 1 is minus 1. So you have a sign of minus. Okay. Let's say I choose -5. -5 plus 4 is -1. So I have a negative. And then -5 minus 1 is -6. So I have a negative. Okay. As usual, just now, positive multiple positive is a positive. Minus multiple positive is minus. So, negative minus multiple negative is a positive. So, you have a conclusion of positive, negative, and positive. Okay, now what you need to do is look back your problems, greater and equal. So, you're going to take the positive. As remember, need to be careful with the equality. Okay, now actually, what is the range over here? Okay, it start from 1. Okay, so it's a 1. Okay, because cannot be equals to 1 until infinity. This one is 1 and -4 and inclusive 4. This one is -4 until negative infinity. So this is the meaning of here, can transform. Okay. Maybe you look at the book, they do it in this way. Either way is the same. As long as you can get the conclusion is this one. Okay. Now we look at the second equation example. It's still the same. Okay, so remember you cannot cross multiple. So now this one, I just shifted this one to the other side. Okay, maybe you say that why can't I shift x over 6 to the other side? You can do it. Okay, no problem. Okay, so I have x over 6 minus x minus 1. Okay, and then this is 0, so less than 0. Okay, equate the denominator and simplify. I get this one, then I factor. Okay, now you have how many factor? 1, x minus 2, x minus 3, and x plus 1. And I can get the critical value is from x plus 1 is -1, x plus 3 is 3, x minus 2 is 2. Okay, so from these 3, I transferred into my real number sign. Okay, this is method of real number sign. So I have my x minus 2. Okay, remember I said, okay, you look at it. Although this one is less than 0, I still can choose greater than 0. This method is the greater is not affected by your problems. Okay, this is your own assumption. Okay, I assume that x minus 2 is greater than 0. Okay, so x minus 2. Okay, but the thing is, remember, everything must be greater or must be less than. Okay, x minus 2 greater than 0, x greater than 2, x minus 3 greater than 0, x greater than 3, and so on. So I plot this inequality on my number line. Whenever you see the line is put a positive, without the line put negative, how you want to get the right conclusion? Just multiple. Positive, positive, positive is a positive. Negative, positive, positive is a negative. Negative, negative is positive, and so on. Okay, so I have my 4 different range of the conclusion. Okay, now how you want to conclude for these problems? Okay, now we look at back to our problem. It's a less than. When this is a less than means that you need to take the negative range. Okay, this is in between 2 and 3. So I'm going to have between 2 and 3. This is -1 infinity. Okay. So that's why. And because this one is an or, okay, cannot be n. And means this must be fulfill both. This is an or. Okay, either you want to use this way or you want to use the inequality. Up to you. Okay, now back to our table sign. Okay, so we start back from here. Okay, first thing, we still have our value negative 1, 2, and 3. Now, choose a number greater than 3 is 5. In between 2 and 3 is 2.5. In between negative 1 and 2 is 0. In between, less than negative 1 is negative 2. Okay, maybe you can say that I want to choose 200, negative 200. Go ahead. Okay, and use this value 5. Substitute into each of these factor. Okay, where this factor coming from? Is from the factor from your problem. Okay, just plug in one of one of each of here, and you substitute 5 into here. Okay, you don't mind the exact value, as long as you know that it is a positive or negative. Okay, so all positive, positive, negative. Okay, if you see the trend, once you saw a negative, definitely the side over here will be negative. It's seldom you get positive, negative, positive, negative, because this is a linear. Okay, linear will be in this way. Once you cross meeting a negative value, so directly the rest of it will be negative. Okay, unless you calculate it wrongly. Okay, so same thing, all positive will produce a positive, all negative, okay, negative, negative, 3 negative will give me you negative. Okay, so same thing, this is how you get the range is x in between 3 and 2. This is negative 1 less than negative 1. Okay, so this is your, sorry, there's no equal sign. Okay, so this is your conclusion. Okay, now we look at the next one, rational inequalities also. First thing, shifted your negative, shifted 1 to here negative 1. Equate the, find the common denominator. So for x, so now if you look at it, this one is a very special case. The upper part, you have a complete square. Okay, so 2x minus 1 square. Okay, so this one you can use calculator, and your calculator will give, let's say, will be give you x1 equals to 1 over 2, x2 also 1 over 2. You don't get shocked. Okay, actually is 2x minus 1. You have a 2x minus 1 square. Okay, any numbers, okay, when you come with a square, it will be always positive or 0. Okay, so let's say negative 1 square will be always positive 1. Okay, regardless what is the number inside, you'll be always getting positive or 0. Okay, so since this part is always greater or equals than 0, okay, so when you have two parts, part A and part B, if part A is always positive, the only controller here is B. Okay, if B is a negative, okay, so I have a positive number divided by a negative number, it will give me negative. If I have a positive number divided by a positive number, will give me a positive. So the controller is always the denominator for this case. Okay, since my A is always positive. Since the question asking to less than 0, so means that I want to get a negative number, so means that my denominator 4x, okay, so to make sure this one less than 0, so my 4x must less than 0. Okay, or my x is less than 0. Okay, so that is my example 3. Okay, there are some exercise for you to try it. Thank you.